Okay, as you saw in the previous video, I explained how this thing works. Basically, it all works out pretty well. The only problem is that I gotta mess around with this timing thing here. I probably gotta put a straight piece of plastic on here because this is catching as it hits the shelf. But other than that, this thing works very well. And we're going to turn this on right here. So basically what you do is here's the input tank and here's the feed tank. You're going to put the caps on this right here. Now with the stage 2, which is this tank right here, and stage 3, you want these to be closed off, and you also want to be primed too. When I say primed, I mean you have to fill them up to a certain level in order to prevent the air from going into these pipes here. So what you do is you fill them up just a little bit to cover over the connectors here, like so. And this is here. And also, you only fill this one up too, right here. The problem is that this thing is going to be sucking up into here, and it hasn't been supplied from here. So this is technically on sort of a suction phase right now, so we're going to have to simulate that. I hate air pockets. Kind of better. Because it's coughing on it. Okay, so we got that little bit right there. I don't know. What the hell's it here? Got some air bubbles in the system. Okay, so what's going to happen is that during the suction phase, it's going to pull all this down into this tank right here. So, God only knows what the hell is going on with this hose right now. But, I'm going to go crank this thing up a little bit. Hold on a second. Let's see what this thing does now. Alright. Sweet. Okay, so now we prime those tanks. We're going to put the caps on. Right here, so put on a stage 1 cap. Right here, so it's all sealed off. Stage 1 likes to leak a lot. But right now I'm just going to leave it as it is. Don't tell me you're leaking. Okay, it's not leaking. God. I've been dealing with leaks in the past and they drive me absolutely berserk. Not fun watching your invention leak. Okay, then we put the cap here on the reservoir so it doesn't just go out the side and you can watch it build up. Right here on the pressurization phase. Now what we're going to do is we're going to start this thing. Okay, we're going to start this thing. Tanks have all been primed. And now going to fill this up a little bit still. Right here. Fill this up right here. And we're going to start it manually, of course, because this thing's catching, so do that. There. Now it starts filling up right here, as you can see. Siphon's still going. Okay, this thing's starting to drain, unfortunately. I'm going to crack that open because I don't want this thing to overpressurize right here. caulking all the damn fittings. This one. Basically what we're trying to do right now is fill up this blue operating tank here, get this filled to the brim, and then what we're going to do is we're going to turn off the suction. We're going to close everything off, and then what we're going to do is we're going to wash this thing, pump the water up with it. Hold on a second. Okay, open up a little bit too much. That's what's going on. Hold on. There we go. That'll do it. Okay, this pipe's risen up. Fill level's right here for this suction pipe now, finally. Now I'm going to close this off, finally. Cut this thing, change its strength. Now we're going to open up the siphon, because this thing's obviously flowing. I don't want it to prematurely flow and just drain the whole thing out. Now this is going. I'm going to close this off, because that's what this is. Exactly what the hell, yeah. As you can see, it's holding the weight all its own because this thing's filled up now. Here. As you can see now, it's going to start filling up, hopefully. Very hopefully. Put a little more into the fill tank. Go. Should be sucking. What technical difficulties we have here. Wow. That's what's going on. Okay, it's filling up finally. Woo! Just had to get the vacuum completely sealed off. That was what's going on. I got totally sprayed. Now it's working. Yes, the container of the trees. So now, as you can see, it is sucking the water up into here. So water's going into the first stage right here. And that's being pulled up from, of course, the feed tank right here. Just slowly draining it down, bit by bit. As you see, it's going below these little water bubbles here. Slowly sucking it through. And this right here is being drained too, very slowly. slowly going down as it gets pulled up into here. And that's just going to slowly fill up right there. You can see. And as this sprayer goes down, suction increases. So, that's how the suction phase basically works. This right here gets pulled down, amount of water and stuff. I gotta fill it around with the timing, of course. It's always just a little, it's ever so slight, the threshold between what would cause this thing to go down, what would go up for the counterweight and the pulley there. You can see right here. So, no, not the trees. Yes. Thank you. Now if we had some 3/8 inch, this would be a lot faster right here. That's what I want to do, is I want to take these out and put some 3/8 inch tubing instead of 1/4 inch OD tubing into this thing. Of course I have to get some new check valves and stuff like that for it, but it's going pretty good right now. So as you can watch, it's filling up. There's so much. And it just continues like that. Okay, I have to go to Lowe's and again and get some 3/8 inch fittings for this thing. Yep, so this one right here, what this does, this fills up and when it's on the pressurization phase, they'll pump it into that reservoir through that tube right there. Oh, it's Manusa, look at that. It's a rarity. You got these things at Walmart. No contradiction. Here's the fill level right there. Water. Slowly sucking it up. And as you can tell, this kind of slowed down too, because what happens is, since there's a suction, even though there's a drop down into here, which is why I added this extra level here, so I can have a bigger drop. Even though there's that large drop there pulling the water downward through the siphon, what happens is that since you have that suction of the air pocket there, that's a negative pressure, all that air is in a negative pressure, is also reactionarily pulling up on the water too, so slowing the flow into the spigot. But you can see just the top of it right there. See, it's marked siphon. A little bit of brass right there between the shelve and the container. And it's still flowing out. Right there. Feels like it's slowing down. Yeah, that's exactly what's going on, slowing down. As you can see, it's doing a great job. Very much amazed by this thing, and I think it's absolutely awesome looking. Really, y'all? Oh, shoot. Ran out of water. That's what's going on. Damn. No wonder. Okay, this thing was at rock bottom. It was sucked all the water out of it, and that's why there wasn't any water coming out of this thing. This thing stopped. Okay, yeah, you gotta experiment with how much water you put into that thing to prime it, because otherwise it sucks it all the way down the darn tube, and there's nothing left of it to pull in, and then this thing turns off. It's like, why the heck is this thing, left in less than half full, and this thing's just over half full? Come, zoom. Yes, thank you for focusing. Okay, so that's why that was doing that. So this thing's filling up, as you can see. Or so slightly. I would so want to replace this thing with 3/8 inches. 3/8 inch couplings, man. My gosh, it's just ridiculous. Look at that. Awesome. Still gotta replace that though. Definitely have to replace that. Drives me bonkers. And unfortunately we have a stunted tank. Not stunted. But, as the camera wants to show you, the leaves on the trees are very nice. Very beautiful looking. And this thing works really good. Just want to put some 3/8 inch tubing on it so it goes a lot faster. I mean, this would be done like nearly half the time maybe. A lot less friction on the surface and stuff too. Surface friction is what's really slowing that down, I think. Not just the fact that it's a little giant, no. It's just a little tiny capillary tube. That right there. So much for intelligent zoom, right? Click. Okay, I give up on technology's ability to be able to touch the screen, and this thing focuses in on me. Okay, there we go. Pressure's on. Look at that. It's almost filled up. This right here would be arguably just about the same place that the one on the bottom would be if only this thing didn't get so low. Which is about to do again. Okay. Okay, that's why I turned it off again. Damn. Now I overfilled it. Crap. Okay. Okay, that's been overfilled, but no worries. If the thing spills over, it spills over. Okay, it's like a second length of fold on the thing. Okay. Alright, now the siphon shut off. Oh, no, it's not shut off yet. Not quite yet. It's dripping. Okay, so technically at this point, right here, everything was switched back, was switched to the pressurization phase. Where what's going to happen is this thing is going to suck like crazy, and I'm going to have to be here with the hose to man this thing because it is going to suck down quick. So now what we're going to do, this right here would have a continuous feed of water going in here. So this would be the high water marker right here, and somewhere down the hill or whatever, this right here would be a low water marker on the ground. So what happened is you would have the fall from here to here, and would bring it up to here, or actually higher. This thing can go much higher. Since you have check valves on it, it can go way higher. I mean, this thing could go like probably 15-20 feet in the air from this point upward. It can go about 20 feet, according to some of the newspaper articles. And with this thing right here, over X amount of time, because there's these tiny little capillary tubes, there's not much to pull up. They could probably go even higher than that. Now, if you, I want to trade this off with 3/8 inch tubing, but this can go much higher than what you see right here. The only thing that depends on how much this thing can climb is the volume of the tank. The volume of the operating tank determines how much suction there is and how much pressurization there is into this pipe here that pushes and sucks, you know, these two right here. That's the only dependency on this whole device here. Other than that, this damn thing, I don't know, it could probably go 1,000 feet. You need a giant tank, but if you did that, you could, you know, take this thing up 1,000 feet. It's all dependent on the volume of this thing. And you could also have several different stages too, and you could probably have regeneration because pressure going from here to here is a lot more than here to here, right? So you could have this thing also, you know, feed back into here with much more pressure than what would come from this tank here. So if there was a fall from here to this tank, it'd be probably arguably twice as much pressure PSI per amount of water coming in than this one right here, basic pneumatics, hydraulics, whatever you want to call it. So we're going to fill this up again right here. Fill this up again too. Okay, now what we're going to do is we're going to trip the switch right here. Pull this up. Now it's open. This is filling up. Ah, man. Okay. I got to do something with the siphon. The siphon's now being actuated. Don't want the siphon to do that. Stop doing that. Turn off. What happens is that when you have an immediate shock like that, it pumps the water right through it. So even though this thing's like this low, the water gets pumped right into the siphon anyway. One thing I got to watch for is the shock, because you want this thing to be off when this is filling up. So we have. What are you doing to me? Where's your leak coming from? Oh God! Don't tell me that. There's another leak. No. What the hell is that? How dare you? Okay, so now there's a pressurization phase. This is pushing down on here. This is pushing down on here, so there's water being pumped into this. And God only knows where the air is coming from on this one again. Lord. Where is this thing sucking? Apparently the check valve broke, because now it's pumping air through it. That's what the air valves are about, as well as the fact that this god-awful thing is actually leaking. You evil sucker. How dare you leak on me? Oh, it's not leaking, don't worry. Okay, what happens is I drill some holes on here. So what happened was this was originally suspended over here, and now it's leaking up the holes. That's why it's leaking. But this is still, can't believe this thing broke up. Evil creature. How dare you? It's like two stupid things that I don't like going on right now. Okay. It's slowly pushing it down anyway. As you can see, the reservoir right there at the top is still filling up, even in spite of the air leak. I'm going to put another check valve on this thing. It's upsetting. full. But as you can see, it's still pushing it up into the reservoir. So right here, as you can see, what it was doing is just pulling it there. And that air should not be doing that. There we go. Stop leaking. Alright, so there we go. So when this thing is properly functioning, and these god-awful McMaster-Carr check valves don't blow up on me, this thing works. The way it should be working. I gotta put more water into it again. I'm not complaining, because it's working. Finally. I'm gonna have to put valves on this thing like you won't believe. I'm gonna have to put a whole bunch of valves on this thing. Just to stop this stuff. Namely the siphon. Siphon is just ridiculous sometimes. You should not be doing that. And in the days of microcontrollers, I don't think I'm going to have to time this thing like one of the top engineers in England ever had to do. The guys who invented this thing, and it worked good, but that guy calculated everything out. I don't have time for that. Okay, so as you can see, it is filling up ever so slightly. I'm going to have to put some valves on this thing. Okay. If we're going to fill this up. What happens is you got to fill the operating tank, of course. And you can see it's still pumping up in there when we get this whole thing straightened out, which I was hoping would be done with the check valves at least. You will see this thing push up very much so. The water, as you can see, is also overflowing into this stage 2 tank here. This tank is just overflowing right now, as the water from the stage 1 is pumping up into stage 2, which is that big, tall, open container. It's just starting to overflow right now. Pretty amazing. And stage 3 right now is pumping up into the reservoir. Right there, as you can see. So as the thing slowly fills up, there's that right there. I have yet to do some more things to this, namely kill this check valve here. Can't believe this is doing that. Really drives me nuts. I see that. Apparently, it wants to leak. So, see, that's the problem. That's why we put check valves on this thing to start with. Should not be doing that. Because what's happening is it's pushing the air from here into there. But even in spite of that, as you can see, that little drip there, that's from the holes that are on the side of this thing. Because I had this thing hanging before, but what's happening is that this is still pressurizing and pushing the water into here. That's why this is still pushing out water. It's not just that the air bubbles are doing that. The air bubbles are only going to go so far to push that. What's going on here is that this is doing this right here. And of course the siphon's now working. I kill that siphon. I'm going to put actually a half-inch valve on that thing. Now, as you can see, that's basically how it works. We have ways to go, very obviously. But it works. I'm just going to open this thing up while I was at it. For the pressurization thing. Okay. Now this thing fills up all the way. It's already filled up again, so actually we should trigger this anyway. Siphon, I guess, is doing its job. All straightened out. And now it's going to start pulling again, provided, of course, the check valve that blew out, apparently, on me. Didn't start using it till today, and apparently just died out on me again. And it's going to fill up again. So, got that all done. Got this thing, suction phase here. I'm trying to which phase is which. So now this is all filled up. Let this thing do its thing. That's where I had to activate the siphon. So now this is slowly pulling down here again. This is filling back up. This is filling back up from this tank right here. So this is all pretty well drained. Hold on a second. I'm also going to have to put a valve on here so in case anything stupid like this happens, I can do it. No, I'm just going to leave it. I'm going to have to put a stopcock or something like that on the thing later on. Hook it fitting up to the bottom of it and have a little valve on there just to drain the thing out. I think all these tanks should have that on them. Oh great, my battery's got 5 minutes left to it. Shoot. Anyway, so as you can see, the thing works out pretty good. Pretty cool. This is filling up right here again. This is being sucked down up into that tank right there. Or so slightly, of course. This is pulling. Hold on, I gotta zoom it. There we go. Look at that. I gotta focus in on it. Look at that. Beautiful, huh? So that's how you can pull water uphill. At least by dividing it through this tank right here. Which is very interesting. Neat little device. Very interesting device. So what happens is when the water goes down, it creates a suction right here. And suction can be used to pull water from this level here up into here, and then pressurizes up into here. Then sucks it up into here, and then pressurizes it back into there. Neat. And this thing was completely dry too. I didn't fill this up or touch that. I just put a cap on it. Amazing, huh? Very, very, very intriguing device. I mean, this thing was you know, pretty big deal back in the day, but no idea what happened to it. No clue. I guess that's business as usual. Just like the hydraulic ram pumps, they went out of business too, and they didn't use any water. This thing's a bit better than a hydraulic ram pump, but you know, and probably weren't all that successful due to the fact that it doesn't use gasoline or diesel. It's not easy. It doesn't. It's very low maintenance. I mean, and look at this damn thing. I mean, the moment when you construct it, it's so low performance. It doesn't beat up its parts or anything like that. So for the most part, you can use some pretty low, low cost stuff to construct this thing. It's not like it needs a lot of high performance stuff. It's not going to be beat up. It's not going to wear down with age and stuff like you see with pumps and whatever. So it's not going to require any parts or anything to replace it. It's a very low maintenance device. So once you get everything all rigged together and tweaked properly, it works just fine. There's no need to replace anything on it. It doesn't run on anything. It just runs on water. That's all. Don't see any extension cords. Oh, there's the extension cord right there. I admit it. Yes. There's the real extension cord. Yes. Of course, if you stick this thing by a riverbed or something like that, I mean, as long as you have a continuous supply of water, you can pump this thing uphill. So you can take it from wherever you want to, and you can go up like 15, 20 feet. So you can pump it wherever. And you just use like an aqueduct or something like that and run a line to it. Or since you have the gravity drop, I mean, the hose can go just like from the top tank, go down, and since it's got that fall, I mean, you just be gravity powered to wherever you want to take it, as long as it's, the destination isn't as high as that. Theoretically, I mean, there's, the amount of volume is going to create some back pressure and stuff like that, and probably some other stuff, but for the most part, it's just fine. So I hope you liked watching it. I have a minute left on the battery. And this is the Hydrautomat, folks. It's very nice. Works very well. Just need to finish up on, just need to deal with the last some of the last finishing touches on this thing. And it's probably going to die out while I'm talking. Darn camera. That's sucking up there. It's pulling into there. And when it's on the pressurization phase, I'll pull it into there. Okay, so that's the end of this. Bye.